Hello everybody, welcome back to another episode of ChemKid. Today, I'm going to show you the build process of this rocket right behind me. Now, this video is part 2 of my series on my Airframe rocket. In this video, we are going to be talking about the fiberglass airframe construction, along with the fins and a couple other little things that we've been doing to it. In our previous video, we explored the parachute, which is a pretty cool project, so go check that out if you want. There's a link in the description. Alright, first off, these are 98mm tubes. They are fiberglass, and these are from Mach1rocketry.com. They have some pretty good rocketry supplies on there, and I'm just starting to dip into, different manufacturers and all that. So that's where I got these. They were relatively low price compared to some of the other places, so that's what I used. First off, let's talk about the nose cone. Now, this is a 5:1 ogive shape, and it has a aluminum tip here. You can see you can kind of screw it out, take it on and off, and then it's 98mm on the bottom, fine tip at the top. It's fiberglass also, really important. Most of everything is going to be fiberglass for this build, not necessarily because it has to be, more because it's a learning experience. I want to learn how to do fiberglass work, and it's going to be built like a tank, and I shouldn't have to worry about it breaking. There are a couple different parts here. First, we have the main body of the nose cone. We have our aluminum tip, and if you look in there, then we have the coupler, and we also have the hardware. First step is going to be preparing the bulkhead. Now, how we're going to do this is we're going to drill a hole in the center, the right size for our eye nut and bolt. When I screw these together, I put a little bit of epoxy on there just to keep them locked together. I know it's not, Loctite professional, but it's going to do better than nothing. So after I epoxied that, then I roughed up the edges and I roughed up the inside of the coupler. Once those were roughed up and cleaned with isopropyl alcohol, bond prepped, then I epoxied them together with a little fillet on the end, just to give it a little bit of extra strength. It's really important when you're doing this that it's strong and that it's done right. Take your time, because this is going to be bearing the weight of the parachute, the whole rocket. It's a pretty important part. It's something you probably wouldn't think of when you're doing this. You need to drill a really small hole in the top of your bulk plate, because if you don't, then when you try to put those two pieces together, you're trying to squeeze a cavity of air and it will not work, and when you have curing epoxy, that's not going to go well. So after I drilled this little hole, then I made sure the bond prep was all good on the inside of the nose cone and the outside of the coupler. At this point, I just lathered everything in epoxy, again using the scale to make sure my measurement was correct, and then I pushed them together. This ended up not going very well, and you see in this video here, I struggled quite a bit trying to get the thing on. There's a weird angle when I put the nose cone onto the coupler, and that caused like a seizure. It wouldn't move, and this was really bad because I had curing epoxy, and I was by myself and nobody could help me. So, I called out for anybody to come help me.
Hey, Dad!
And then thankfully I was able to get it out.
I got it.
And yes, my feet are here, but true engineering is done with the dogs out. Now, everything in this video that deals with gluing or epoxying fiberglass together, there's something really important. That's called bond prep. Now, for bond prep, I use primarily isopropyl alcohol, which is recommended by the manufacturers of this epoxy that I use. And then it's really important, you want to sand and you want to rough up and get a lot of surface area. After you sand everything down just to get that extra surface area, it's a good idea to go ahead and wipe it down with the isopropyl alcohol. Make sure it's free of dust and oils, anything that could possibly prevent epoxy from bonding to it. Now, in this video, you're going to see pretty much everything I epoxy is going to be with this. This is Rocket Epoxy by Glenmark, G5000 Rocket Epoxy, and I'm going to be referring to it as
G5000 Rocket Epoxy.
We're going to be using this a lot through the video. The reason I'm using it is because it is built specifically for building rockets. It's really strong and it's really thick, which allows me to do fillets on fins, and overall it's just a good product. Big fan and highly recommend it. You'll see here that every time I am measuring out epoxy, I'm doing it with a scale, and that's just to get really accurate measurements, because the last thing I want to happen is too brittle of an epoxy or epoxy that doesn't cure. That would be really bad, and it would be really hard to get off the rocket. So I'm using a scale to make sure my measurements are precise. Make sure to wear gloves, because you will get epoxy everywhere. It is inevitable. You will get epoxy everywhere, all over your hands and stuff. So make sure you're wearing gloves and your workspace is done on something like a mat here. This is what I use just to, keep the epoxy off of your furniture. Generally a good idea. If you happen to spill any, you can wipe it up with isopropyl alcohol, but generally you want to avoid spilling altogether. So now that the nose cone was finished, it's time to talk about the rest of the rocket, mainly this airframe tube. Now this is 98mm fiberglass tube, and you might not think it to be too hard to cut, but if you're wanting an exact right angle cut, it's actually a little bit harder than you think. Now when you're cutting fiberglass, something you got to keep in mind is you don't want it to chip or fracture, and that can happen if you're using the wrong blade. Here I'm using a chop saw with a lot of teeth on the blade, and they make specific ones for fiberglass, but really the only difference is a lot of teeth. So that's what I used to cut this. A really important disclaimer: whenever you are cutting or sanding fiberglass, please, please, please wear a respirator or mask. Fiberglass is really good for rocket building, and it is really bad for your respiratory system. If you get fiberglass in there, it's not going to be fun. So just take the extra time, wear a mask. Fiberglass is really bad in your lungs, so do not inhale any of this dust. Now with all the tubes cut to size, we can start assembling different parts of the rocket. Now there are three main parts to this rocket. I have the top, the nose cone part, I have the middle, which is going to be our electronics bay, and I have our bottom part, which is going to be the fin can and the motor tube and stuff like that. First on this list is attaching the nose cone assembly to the first. This is really straightforward. All you got to do is bond prep this tube, bond prep the coupler on the nose cone, and put the two together. It's as simple as that. It's important to note that a friend can be really helpful when you're building stuff like this, because if epoxy's curing, you might need an extra hand to help you get things done before something goes wrong and you have permanently glued a $100 piece of fiberglass. That's really not good. Me and a friend glued that piece together, and here's some footage from that. This is my friend I employed for manual labor of sanding parts.
Really fun.
You already got it on your gloves? Just the tiniest little bit, yeah. Okay. Really good. That looks really delicious. Okay. Basically, even if it's really thin, just try to coat everything I wonder why you aren't satisfied. Okay. Let's just salvage it what we can so we can use it on the next part. That's good. Yeah. Okay. Out of the way for now. Ooh, that's bad. The drips on the inside.
I know, I was thinking that.
I didn't see those. It's actually not great.
No, that's... Is there...
Here, I need
it's
the
not
special tool for moving the tape. Anything sharp. Yeah.
What's the situation?
Show the YouTuber crew.
Oh.
It's a thin. It's not that bad. It's
Yeah,
not.
that's not bad.
It's recoverable.
I'll show the YouTubes. What does it look like?
Here. Yeah, you guys see those drips? That's bad. One more. You wanna?
It's looking a lot better.
Next item on our list of big parts is the electronics bay. Now we're actually going to have its own dedicated video to the details, but here, since it's part of the airframe construction, it's as simple as taking a 6-inch or so piece of 98mm tubing and about a foot of this coupler tube. Then I just bond prepped everything and glued them together.
It's engineering, guys. Here's a blank piece of paper, no ruler.
Start designing. What's your robot gonna look like?
Shove them up, scribble. Oh, that's really great. Yeah. Go ahead and build it.
Approved. Here's your $20. Okay, just put it down.
That's like...
Welcome to ASMR. Should we stop halfway down and like smooth that out so we can put it on the uncoated?
Okay, there we go. Just hold it.
Well, what's funny is like neither of us know what we're doing. We just kind of, but we're both smart enough we can figure it out. I can't tell like how much glue is actually going on.
I know.
The nice thing is this isn't a, it's not a vastly structural thing. Okay, we're gonna have a little bit extra, which is good, but we cut it close. I was worried. Ah, it's getting everywhere. Okay. Good thing, like the alcohol, we can.
I wish the camera had caught that.
But the mistake I just made. This is rocketry, guys. Alright, cleanout time. This is as far as we'll go for like details on the electronics bay in this video. Really, all you need to know is that was the airframe part, made of fiberglass, and then I got some 3D printed bulkheads. These are likely just temporary. I probably won't keep these. I'll probably replace them with fiberglass. Not totally decided yet, but we'll find out later. What I then did is I took some 304 stainless steel parts, specifically a eye bolt and some 304 stainless steel rod, which is this length here, and I welded it at the top here, so that way it's not going to come undone during flight. It's just one more redundancy. The bottom one can come undone and, you know, twist off like this, and that will give us access to the inside of the electronics bay. More details to come in the next video.
There we go, just welded it. Not a great welder, but that works.
Now this is probably the most labor intensive part. This is the fin can and motor assembly of the rocket, and there are quite a few parts to get it all going, and it was quite a challenge. Now the motor for this rocket is going to be a 54mm diameter motor, and this is a 98mm diameter tubing, so we need to adapt that size change. To do that, we have something called a motor tube and centering rings. That's what you see in there. Now I made a really bad decision, and that was I put in the centering rings before I put in the motor tube. And the reason that's bad is because you need some way to attach your parachute to your bottom of the rocket, and usually people will go with their centering rings and they will drill a hole and put an eye bolt there, and that's what they'll connect all their chute lines to. Now I had just put them deep in the rocket where I wasn't going to be able to reach them with a drill, and if I could, it'd be really hard, and then I would have to tighten. Somehow I was going to have to tighten up a nut, and I don't know how I was going to do it. I consulted with a friend, and here's our discussion. This is my tube here, and you can see it's already glued in, which is the problem. This is the motor mount tube, which will go in there. I have a couple options. One, I could drill a hole for the eye bolt to go in. That's going to be really hard to tighten the eye bolt in there. That's obviously going to be an issue. But something else I was thinking, I could take the Kevlar and, I would have it would epoxy it directly to the motor mount tube and make a little notch in the, centering ring, which a lot of people do, but I was a little bit concerned with it not being strong enough. So I have an idea. My concern is that is permanent, and you can't untie the Kevlar or anything if you ever wanted to. So my idea is, okay, well, what if I cut this here? So basically we have two strips attached to the tube, and a little loop hanging up on top. So then this tube here will go in, there'll be a notch cut in the side of the centering ring for this to come out, and then this little loop will be the only thing sticking out. So it'll just look like this coming out of the centering ring. And this is what I can tie my Kevlar stuff onto. This is what I can do all that with. The benefit being, I can untie and change stuff, and the benefit being I don't need to figure out how to do the eye bolt. So that's what I was thinking.
Okay, so I think your idea with cutting it and then having the two pieces in the loop on the end of the centering ring would be good. I didn't see any big issues other than maybe it losing some of its integrity from cutting it, but I think it should be fine depending on how you attach the pieces. And I think that loop should be enough to attach everything to. Probably. Yeah. So I guess my only worry is the notch in the tube and for the rope, or the notch, just decreasing any integrity just a tiny bit, but I think it should probably be fine. Yeah.
After I confirmed my idea with a friend, we decided that was probably a safe bet. What I did is I took the Kevlar line and I epoxied it directly onto the motor tube. I was a little concerned that maybe the motor would get hot and that would weaken the epoxy, so I did two different types. I did my really strong
G5000 rocket epoxy
on one half, and I did some high heat epoxy for the other half. It was actually really hard to find the high heat epoxy, but you know, I guess auto parts stores had it, so I went to O'Reilly to pick it up.
Alright, so we're here at O'Reilly. We got some high heat. It should work.
Now, after the fact, I think that that was probably the best bet. Gluing the Kevlar to the motor tube is probably a lot stronger than if I did it to a bulkhead. So, in hindsight, you know, maybe I should have done this method, not what everybody else does. If you're a rocket expert out there, you know, let me know if I did something catastrophic, but I think it's a pretty good decision.
Alright, so I got the notch all cut. Next step.
We get to wash our parts in the shower here. So after everything was bond prepped, I slid that motor tube into the main tube with those little centering rings like I said before, and that was pretty easy. Important to note that I needed to cut out a little notch that was somewhere for that Kevlar to go through, and now we should have a pretty strong linkage. I bond prepped everything, and then I slid in the motor tube, epoxied everything together, and I got a pretty good result. Now the lower coupler we had to drill a couple of holes in, and the reason for that is because we have something called a thrust plate going on that. Now the thrust plate is going to transfer force from the motor directly into the rest of the airframe, and what that'll do is that means we won't have any stress on our motor tube or that bulkhead. And before I closed everything up at the motor tube, I drilled a hole for the launch lug. This is really important. If you don't have it, your rocket's not going anywhere. So I drilled a hole for the launch lug, screwed it in, and added some epoxy so it wouldn't be going anywhere. So now we have the completed tube, and it looks like this, except these fins. Where did the fins come from? That's what I'm going to tell you. Now for the fins, I decided to use 3/16" fiberglass, and you can see it right here. It's pretty strong, although that wasn't a good test. Now this is made out of G12 fiberglass, and it's relatively inexpensive. I mean, it still cost a lot, but it wasn't that bad. I got it off McMastercar.com. Next thing I did is I traced out where we had to cut on the fiberglass sheet for the fins, and then I actually cut them out, and then I sanded them to get a nice pointed edge.
So we got my fins all sanded here, and we're gonna start gluing them onto the body.
Now, one of the other things we had to do for the fins is print some sort of jig to hold all the fins straight while they're being epoxied, and this was kind of a disaster. I used some junk PLA for my 3D printer, and I printed out a custom-made jig, but after coming in the day later for the print, it broke.
Here in the utility room, we have a print going. broken.
It's actually okay, and it turns out I could use it still, so I went ahead and started gluing on the fins. So the fins are on the rocket, and it's actually starting to look pretty cool. It's looking like a finished rocket. Now, there's something you need to add though. These are called fillets. Now, the fillet is this curved section right here on the rocket. You might notice, it's not just a right angle. You want a fillet here, and what that's gonna do is that's gonna make your rocket fins a lot stronger, better. Before, with just that joint, I could probably just break that off with my hand. But now with this epoxy, I could almost stand on it and it would support my weight. To do this, I used my favorite
G5000 Rocket Epoxy.
I used this with a couple 3D printed little fillet jigs, and I mixed up the proper amount of epoxy and I put it in here, and then I took that jig and I smoothed it out until we had the right shape. Now, making these fillets was not fun, and I'm still a little disappointed because they weren't perfectly, concave. They did tend to settle a little bit while curing, but that's really just cosmetic, and really this is just as strong. This is stronger. Now, after the fillets were all done, there was lots of sanding. This project involved so much sanding. There was sanding here, there was sanding there, and there was sanding everywhere. This rocket had so much sanding, and if you don't like sanding, you should not build rockets. You must enjoy sanding, which I don't, but here we are. That's pretty much it for the fin can. It's a different color here, but that's just because I've been sanding it a bunch, and I put a primer on it, and I'm going to sand it more and prime it more. There's a lot of, fine cosmetic stuff that I want to do, but you don't have to do this yourself. Alright, so I am currently editing the video right now here, and I realized I did not record an outro. So I hope you guys enjoyed the video. This has been a really fun project, and I'm going to keep uploading on it. If you enjoyed it, please like and subscribe, and I'll see you guys in the next video. Bye.